Climate change, arguably the most dangerous threat to most living organisms, humans included, is creating drastic and rapid changes to Earth at a speed that has never been seen before. Ice caps are melting, sea levels are rising, weather is getting more extreme, and the globe is warming year after year. Species are constantly going extinct, and the ability to reverse the damage is drifting away year by year. However, one massive issue seems to be glossed over. The ocean is the home to countless species, and its depths are still mostly unknown to humans, with hundreds of thousands of known species, but many more unknown inhabiting it. 70% of the Earth's surface is covered by large water masses, but ocean acidification is starting to take a large toll on these species and the ocean's ecosystem. But what is ocean acidification? Why should you care? The ocean acts as a natural carbon sink, with about 1/3 of the world's carbon dissolving into the ocean. After the carbon has dissolved, the carbon atoms react with water to create a new compound, carbonic acid. This carbonic acid then takes the necessary carbonate needed by marine life, such as coral and other calcifiers, to create their shells and skeletons. This leads to a degradation in survival and reproduction for many sea creatures. They will expend too much energy trying to incorporate the depleted amounts of carbonate ions into their shells, and not enough energy trying to find food. With the possibility of calcifiers such as coral reefs dissolving, we are faced with the potential breakdown of the ocean's food chain, as 1 in 4 fish depend on coral reefs for food, shelter, and reproductive purposes. Models created by the World Meteorological Association predict that by the middle of this century, carbonate ions level will be so low that tropical coral growth will be all but impossible. The chain reaction caused by a lack of available carbonate ions to sustain coral and wider marine life can directly result in a seafood shortage. This is concerning, considering that 1 in 7 people globally rely on seafood as a main food source. The shellfish industry in particular is vulnerable, with studies done by the National Oceanic and Atmospheric Administration finding that some species have already begun suffering significantly, such as the Dungeness crab. Even more concerning is the ocean's increasing inability to act as the natural carbon sink that it is. While the ocean has been absorbing approximately 1/3 of the carbon from the atmosphere, it is struggling to keep up with the balancing the massive amounts of man-made carbon emissions. Since we began burning fossil fuels, the ocean has absorbed over half of the CO2 released. The near-surface ocean's capacity to absorb carbon is at 70% of what it was in the pre-industrial era, and this percentage is expected to drop to only 20% by the end of the century. Now that we know the effects of ocean acidification, let's look at the causes of increased acidity. Why is this happening? The answer? Humans. The ocean is warming up via heat waves produced from factories. Factories burning fossil fuels such as coal, oil, and gas cause CO2 levels to rise in the atmosphere. Activities such as vehicle emissions and deforestation also significantly contribute. When trees get cut down, they cannot absorb the CO2 in the air, and when they are burned or cut, the carbon they are absorbing and made out of ultimately gets released as well. Since we started burning fossil fuels, the ocean has absorbed over half of the CO2 we have put out. In the context of paleoclimatic records, the current rate of change of ocean acidification appears to be fastest seen in 300 million years. So what can we do to reduce these rates? On an individual level, we can each work to reduce our carbon footprints during our time on Earth. We can do this by eating a plant-based diet, driving cars less, and utilizing non-fossil fuel energy sources. In addition, remember the 5 R's. Refuse, reduce, reuse, rot, and recycle. Refuse any single-use plastic or paper products. Reduce your purchases and be mindful of what you choose to buy. Reuse items and keep them out of landfills until necessary. Set up a compost system for your food scraps and properly recycle any plastic, paper, or glass that enters your life. As for a bigger picture, seagrass is commonly mistaken for seaweed, but it is significantly different. Green seagrass beds can help reduce the amount of CO2 that goes into the ocean because seagrass absorbs CO2 and releases oxygen as shown in the figure. Based on studies, this effect may have a big enough impact on the CO2 chemistry to make a significant difference. Seagrass has the potential to save our oceans, so we must work on saving the grass and planting more. Now it's up to you to make the change to save our oceans.